Bo Maths.
Well, hello everybody, and welcome back to Bo Maths. I hope you all had a lovely holiday season, and we are going to be kicking back with some neat divisibility rules for 4 and 8. So in the last video, we discussed how with all composite numbers, we were able to basically split them up into their prime factorizations and determine different divisibility rules for them based on different co-prime factor pairs. But for situations like 4 and like with 8, we noted that, well, their prime factorizations appear as follows, and there weren't any co-prime factor pairs that we could make for them. So what that meant is that the divisibility rule we had to make for them was essentially that a number can be divisible by 4 if it can be divided by 2 different times, right? So like 16 was divisible by 4 because we could divide it by 2 once to get 8, and then we could divide it by 2 again to get 4. We saw that for a number to be divisible by 8, it had to be divisible by 2 3 different times because it has, well, these 3 factor pairs of 2's. So for example, 24 is divisible by 8 because we can divide it by 2 once to get 12, then by 2 again to get 6, and then by 2 again to get 3. However, we noted that these rules weren't very effective because essentially what we're doing is we're just dividing by 4 when we're looking for if the number can be divided by 2 twice. And we're dividing by 8 if we're looking for if the number can be divided by 2 3 different times. And of course that is what it means to be divisible, right? To be divisible means we can divide by the number without having any remainder or without having any decimal. However, the whole purpose of divisibility rules was essentially for us to make it more efficient to check if the number was divisible by something without actually having to divide by that number itself. It was meant to be kind of a shortcut using the properties of these numbers. So now I'm going to present a slightly more efficient method to determine if a number is divisible by 4 and if it's divisible by 8. So let's start with 4. Alright, so to start off, I'm going to list a lot of the different multiples of 4. So I've listed a ton of different multiples of 4 here, and you might think it's a little overkill, but I did it for a very specific purpose. So let's note we have 4, 8, 12, and so on, and then we just continue these numbers, but what we see here is that eventually we get to 100, right? And then we have 104, 108, 112, and so on and so forth. But what do we notice? Well, we notice that here we had a 4, and then we had 104, 8, 108, 12, 112, 16, 116, and so on and so forth. So basically all of these numbers that we had before are going to get repeated just with the 100 slapped in front of it. And since 100 is divisible by 4, that means any multiple of 100 is going to be divisible by 4. So 200 will be in this list, and 300 will be in this list, and 400 is going to be in this list. Right? So all of these numbers are going to be divisible by 4. So since all of these numbers are going to be divisible by 4, that means that we essentially know that we're going to have 204, 208, 212, 216 that are going to be divisible by 4. 300, 304, 308, 312, 316, and so on, going to be divisible by 4. 400, 404, 408, 412, 416, and so on, going to be divisible by 4. So what we're kind of noticing is that basically this 100, 200, 300, 400, since those are always going to be multiples of 4, we really need to just check these last 2 digits of the number, and if they're kind of one of these original that we had, the number will be divisible by 4. So for example, 444 is divisible by 4, since, well, the 400, that's guaranteed to be divisible by 4, since, well, it's a multiple of 100, and 100 is divisible by 4. So then we just really need to check this 44 part. But 44 does appear in the list of our first 2-digit numbers, right? 44 is right there. So it's a 2-digit number that's divisible by 4. So that means 444 is going to be divisible by 4. So then if I said, all right, let's consider 128,328. So since the 128,300 part is a multiple of 4, right, because it's a multiple of 100, we only need to worry about the 28 piece, and the 28 piece is divisible by 4. So that means we can say with confidence that this number is going to be divisible by 4 without having to check anything further. So while this is still a somewhat more complicated rule where we need to still kind of check if the 2-digit part is divisible by 4, it's a lot more efficient than what we had before, where we had to divide this whole number by 2 and then divide it by 2 again. All right, so then let's just do one more example. 151,270,309. All right, so this is a massive number, right? But all we have to do is we know that this first portion here, the 151,270,300, that's a multiple of 100, so therefore it's divisible by 4. So we only need to worry about the last two digits, which is just 9. 9's not a multiple of 4, so therefore the number is not going to be divisible by 4. So for practice with this, just do it as you would normally do it. Pick random numbers and see if they're divisible by 4, but try and use this method where you just look at the last two digits of the number. All right, so let's move on to the rule for 8. So 8 isn't quite as convenient because 100 is not divisible by 8. We would be adding by 8. Eventually we'd get to, so we'd start at 8, 16. Eventually we're going to get to 80, and then 88, and then 96, and then 104, and keep on going. So we see that we skip over 100, right? So 100 is not a multiple of 8, so it's not divisible by 8. However, 200 is divisible by 8. 200 divided by 8 is 25. You can go ahead and check that. So that means on this list, 200 is going to be there. All right, so then we can continue. And we'll then know that every multiple of 200 is going to be divisible by 8. So 200, 400, 600, 800, 1,000. And we just keep on going here. So we know that all of these are going to be divisible by 8. Now what I want to focus on in particular is we're able to kind of go 200, 400, 600, 800, 1,000 are divisible by 8, but the 1,000, I would say, is the most important one we can look at is divisible by 8, because that means any multiple of 1,000 is going to be divisible by 8, right? 2,000, 3,000, 10,000, a million, a billion, right? All of these numbers are going to be divisible by 8 as long as they're a multiple of 1,000. So then, kind of like with the divisibility rule for 4, we're able to break it down further and say that, all right, the number is divisible by 8 if the last three digits are divisible by 8. All right, so for example, 5,888. We don't really need to worry about the 5,000 because that's a multiple of 1,000, so therefore it is divisible by 8. So we just need to focus on if the 888 is divisible by 8, which it is, right? It's got a bunch of 8s in it. 888 is just 8 times 111, so that means it is a multiple of 8, so this whole number is divisible by 8. All right, we could try 1,200,000. A million being a multiple of 1,000 means it's a multiple of 8, which means it's divisible by 8. So again, we just have to focus on the last three digits. 200 is a multiple of 8, right? We showed that up here. So we know that this number is also going to be divisible by 8. Now, admittedly, this isn't quite as easy as the divisibility rule for 4, because let's say I gave you the number like 4,138. Okay, so I give you this number, and we know, yeah, okay, 4,000, that's divisible by 8 because it's a multiple of 1,000, and we just have to check the last three digits. So to check if 138 is divisible by 8, the best way to do this may actually still be using the divisibility rule we talked about in the first place, where we had to take the number and divide it by 2 3 different times and see if it was divisible by 8. So we take 138, divide that by 2, we get 69. 69 is odd, can't be divided by 2. So we already see that this number will not be divisible by 8 since this number cannot be divided by 2 3 different times. All right, so this number isn't divisible. So we don't completely get out of using the rule I introduced in the last video. However, we do get a little more efficient method about going about it where we just have to check the last three digits of a number. So for example, if I gave you this number here, we don't have to worry about dividing this entire thing by 2 3 different times to see if it's divisible by 8. We can just focus on the last three digits. So if we start with 274 and we divide it by 2, we get 137. That's odd. It's not divisible by 2 any further, so that means this number will not be divisible by 8 because we weren't able to divide it by 2 3 different times. So we didn't get away from using the rule, but we were able to use it in a simpler setting than we would have otherwise. All right, so just to summarize here, we're able to simplify the rule into being a number is divisible by 4 if its last two digits are divisible by 4. And for 8, we could say a number is divisible by 8 if its last three digits are divisible by 8. So both of these are just us simplifying the situation down to the last two or the last three digits, making it a more easy problem to deal with, and we're making it an actually efficient divisibility rule. Alright, well, I hope you found this video interesting, and now you have a slightly more effective way to look at if a number is divisible by 4 or by 8 than what we were looking at in the previous video. If you want some practice with this, just choose some numbers, pick really big ones, because again, all that matters is the last 2 and 3 digits, and see if they're divisible by 4 or by 8. Just do this a bunch, you'll get a hang for it, these rules will become second nature to you, and you'll be good to go. Have a good one, stay groovy, and I'll see you in that next video.
F.O.A. maths.